Hello everyone. Welcome to this video. I want to continue talking about entropy, and I'm going to introduce a new concept here which is called as information gain. So what we discussed in the previous videos is that after splitting a given node, we measure the impurity of the child nodes, and it is desirable to have a low impurity in the child nodes. And that would mean that our splitting attribute has been able to separate out the classes in the outcome attribute better because the resulting nodes have low impurity, or in other words, the resulting nodes have low entropy. So what we discussed is that impure entropy is a measure of impurity, and then if a node has less impurity, then it has low entropy, which is closer to zero. And if a node has high impurity, then it has high entropy, because entropy is a measure of impurity. Now, what we want to discuss here is this new concept of information gain. So basically, what we're saying is that once we have used an attribute to split a given node, and we go and measure the entropy of the child nodes based on the decrease in the entropy after the data set is split on an attribute, we can measure what is known as the information gain. So let me say that in different, let me frame it a bit differently. What we will do is we will look at the entropy of the parent node, and we will compare it to the combined entropy of the child nodes. And we want the entropy to reduce after the split. And we will measure this reduction in impurity. The reduction in impurity is called as the information gain. And why is it called as the information gain? Because this is the new information that we have gained, which will help us to separate out the classes from one another. So remember, the objective of decision trees when we are using it as a classification tool is to separate out the classes. If the classes in the outcome attribute have a value of yes and no, basically every splitting point in a decision tree is to help us understand how to separate out the yes from the no's a bit better. And that is why the information gain is the reduction in entropy after a particular node has been split. So we will compare the entropy of the parent node with the entropy of the child nodes, and the reduction in entropy is what is known as information gain. And just to summarize it, constructing a decision tree is all about finding attributes that return the highest information gain. So what do we want? We want to choose attributes that give us the highest reduction in entropy, and in other words, that give us the highest information gain. Okay, so this is what we want to do here. So now let's talk about something else, that how do you identify the root node? So root node is the starting attribute. Okay, so you have an entire data set which has mixed classes in it, and you want to start with one single attribute in the root node. So the root node is basically the attribute that gives you the maximum information gain. So remember, when you're trying to decide the attribute that should be used as the root node, you will calculate the entropy of the entire data set, and then you will use a particular attribute to split the entire data set into child nodes, and then you're going to compute the combined entropy of the child nodes. And from there, you can measure the information gain. So whichever attribute gives you the most information gain will be the starting point or the root node. Okay, so basically that's what we will be talking about. And so you can ignore this statement here, because I will not be talking about Gini. I will only be focusing on entropy for this particular course. So what I want to do is basically in the next video, I'm going to talk about this example that we will be using to calculate entropy. So before I end this video, I want to talk a little bit about what's in this data set, and you can either pause the video or after the video ends, you can go through this to summarize your understanding of this particular data set. So this data set is basically the example that I had talked about in the beginning. The decision is whether you can go out to play or not, and it takes yes or no values. So the classes that we want to separate are binary, yes or no, and the decision of going out to play is based on a few aspects of the weather for the day. The outlook, which takes values sunny, overcast, and rainy. The temperature, which can be hot, mild, or cool, and then humidity, which can be high or normal, and then windy, which is either it is windy or it is not. So it takes value true and false. So this is the data that we have, and you can count the number of observations. It's 14 in this data set, and we have four attributes: outlook, temperature, humidity, and windy. And the first decision that we want to make is that which attribute should be chosen as the root node. Okay, we will do that based on the measure or calculated value of information gain. Okay, so first what I want you to do is to see that how many values, how many observations fall under each of the values of outlook. So we are going to start by trying out outlook as the root node, and we are going to repeat that for temperature, humidity, and windy, and then we will compare the information gain value from the four attributes, and the one that gives us the most information gain is going to be our starting root node. So you can see that basically sunny is 5 observations in this data, take value sunny. And then when we look at overcast, it's basically 4 observations here. And then we have 5 observations for rainy. Okay, so this is the data that we have. In the next video, I will talk about the formula of entropy, and we will apply entropy. We will calculate entropy on this particular data set of 14 records for our getting started exercise here.